Project 3.1 CharliePlex Clock. This project is a CharliePlex LED clock built using an 18 mega 328p SMD microcontroller, a 132 LED CharliePlex array, flat flex cables, and user input buttons. The goal of this build was to create a compact and efficient clock that displays hours, minutes, and seconds using as few microcontroller pins as possible. How it works. CharliePlexing takes advantage of the fact that each I/O pin on a microcontroller can be set as high, low, or high impedance. By carefully switching between these states, the clock can control one specific LED at a time, even though all the LEDs share the same set of pins. The number of LEDs that can be controlled is determined by the formula n times n minus 1, where n is the number of pins used. In this project, 12 pins are used, which gives us exactly 132 LEDs, enough to represent all the hours, minutes, and seconds on the display. Each second, a timer interrupt fires to increment the time count, and the LEDs corresponding to the current hour, minute, and seconds are illuminated in sequence. Because of CharliePlexing technique cycles very quickly through the LED, persistence of vision makes it appear as though multiple LEDs are on at once, creating a stable clock display. The external 32768 kHz quartz crystal provides the timing reference. It's configured as a Pierce oscillator using an inverter, two capacitors, and resistors. This clock is the same type used in real-life clocks, vibrating at a constant frequency to ensure accurate 1-second intervals. The timer interrupt divides the signal down so that exactly one interrupt is generated every second, which keeps the time precise. User input is handled through a button and SPDT switch. The switch determines whether pressing the button adds an hour or a minute. When the button is pressed, an external interrupt triggers instantly so that time can be adjusted without delay. This interrupt-based system means the main loop doesn't have to constantly check for button presses or timing. Everything happens automatically when needed, ensuring the clock remains accurate and responsive. Once the basic CharliePlexing and timing logic were working correctly on the breadboard, the design was transferred to the official Charlie Clock PCB. The final version uses an 18 mega 32AP in surface mount form directly soldered to the board. This SMD version is identical to the one of the Arduino Nano, but much more compact and better suited for permanent installations. To program the SMD controller, flat flex cables or FFCs are used instead of traditional headers. These flexible cables can make it possible to upload code directly to the microcontroller while keeping the design slim and organized. They also prevent mechanical stress on the solder joints, improving durability and long-term reliability. The physical assembly of the project was built into a 3D printed replica of Montreal's Olympic Stadium. The CharliePlex LED sits at the center of the structure, while the PCB is housed below it. Buttons and switches are neatly mounted for easy access, and all wires are routed to avoid interference with LEDs or moving bleed. Unfortunately, during testing, a wiring issue was discovered on the PCB. However, the 3D model was quickly adapted to accommodate the breadboard version of the circuit, allowing the prototype to function as intended and keeping the project on track. Now onto the code. So we're in for the 18 mega 32AP using the timer1 library to handle the 1-second interrupts. At the top, all the CharliePlexing pins are defined, from P1 to P12 according to the 12 I/O pins driving the LED arrays. Additional pins are assigned for the user button and the hour-minute switch inputs. SF3 ways defines the specific anode and cathode pairs for the hours, minutes, and second LEDs. These arrays tell the program exactly which pin to activate for each time value. The code uses two interrupt service routines. The first is second ISR, which sets a flag every time 1 second passes. The second is button ISR, which sets another flag whenever the button is pressed. In the setup function, the timer1 library is initialized to trigger an interrupt every 1 million microseconds, or exactly 1 second. The button pin is configured with an internal pull-up resistor attached to an interrupt on the rising edge. The switch pins are set up so that, depending on the position of the switch, pressing the button adds either an hour or a minute. The loop runs continuously, checking the flags set by the interrupts. When 1 second flag is triggered, the program increments the seconds, and if needed, rolls over to minutes and hours. When the button flag is triggered, it checks the switch position and adjusts the time accordingly. To display the LEDs, the program calls the display LED function, which sets one pin high and another pin low to light a single LED corresponding to the current hour, minute, or second. The function resets all other pins to inputs before each display cycle to prevent multiple LEDs from lighting up simultaneously. Serial outputs are also included for debugging, showing the current time and format, hours, minutes, seconds. Overall, this project demonstrates how CharliePlexing can be used to drive a large LED display using minimal pins while maintaining precise time control through interrupts and an external crystal oscillator. Building the CharliePlex clock requires combining hardware, software, and careful timing management to ensure each LED lights exactly when it should. The final result is a fully functional 132 LED CharliePlex clock. Thank you for watching.